Hello everyone, and then welcome to another video. Okay, so this video is going to be very short and then concise. We'll be treating how to find out the linear independence or dependence of two functions, okay, specifically differential equations. Okay, right. So in case you are new to this channel, don't forget to subscribe. Okay, hit on the bell icon so that you don't miss out on any uploaded video. Like the video and then let me know your comments in the comment section, and then don't forget to also share the video to your colleagues. Okay, right, so let's dive right into this video. Okay, so in this video we'll be using the Wronskian method. Okay, the Wronskian method. So the Wronskian method is simply just like finding the determinant of what a matrix. Okay, but this implies some form of differentiation. Okay, so let's see how this method is all about. Okay, so maybe whenever you are given two functions, okay, so let's say function f of x and then maybe g of x. Okay, so you take the determinant, okay, of the two functions, okay, and then you take the derivative of those two functions. Okay, so after taking the derivative of the two functions, you take the determinant of those functions. Okay, so after taking the derivative of those two functions, the functions become 4. Okay, so after that you take their determinant. Okay, so now these are the original functions, okay, f and g, and then these are the differentials. Okay, so that's f prime and then g prime. Okay, so once you take the determinant, f will multiply g prime, that's over here, and then you have this f prime also multiply g. Okay, that's over here, right? So that's how you take your determinant. Okay, it means that once you are studying this course, that's differential equation, it means you've already treated matrices. Okay, so you know how to find determinant. Okay, now let's proceed. So let's look at the rules. Okay, so in order to know that a certain function or two functions are linearly independent, once you take the determinant of the differential of those determinants, okay, and then your answer is not equal to 0, it means that the function is the functions are linearly independent. But once you find your determinant and you get the exact opposite, okay, or the two functions or the determinant of the functions end up being equal to 0, it means that those functions, okay, are linearly dependent. Okay, so these are the two rules we normally use in concluding on our final answer. So these are some two examples we need to solve so that we will verify our technique or our method, okay, that's using Wronskian. So now let's see how we go by this. So we have f of x, okay, to be equal to cos x, right? And then we have g of x being equal to sin of x. So now let's take their differential. Okay, right? So we have cos of x will give us when you differentiate cos of x, you end up with minus sin of x. Okay, and then once you take the differential of sin of x, you end up with cos x. Okay, right? So there we go. Now let's take the differential. Okay, so we are taking the Wronskian of those two functions, okay, f and then g. Okay, right? So we have f, g, and then f prime and g prime. Okay, so this is equal to f is cos x, okay, and then g is sin x. Okay, and then we have f prime of x, that's minus sin of x, and then we have g prime of x, that's cos x. Okay, so let's solve this. Okay, so we have this multiplying that, so cos x multiplying cos x, we have cos squared x, okay, minus sine x multiplying sine x, okay? So we have what? Negative, so we have positive what? Sine squared of x, okay? And then from this we know that per the trigonometry rules, we know that cos squared x plus sine squared x will give us what? 1, okay? So it means that this value is not equal to what? 0. It means, so in simplicity or in conclusion, function, okay, this question is what? Linearly independent, okay? Linearly independent, okay? Right, because this is not what? Equal to what? 0, okay? It means that it's something other than what? 0, okay? So now let's proceed, okay? Let's solve the second question, okay? Okay, so let's solve the second question, right? Okay, so the second question is what? We have what? F of x is a exponent s, and then we have g of x, okay? So let's solve that. So we have f of x, okay? This is question 2, so we have f of x, okay, being equal to e exponent x, and then we have g of x, okay, being equal to x, and then we have e exponent what? X. So let's take the what? First differential, okay? Right, so when you take the first differential for e exponent x, okay, and then when you take the what? G prime of x, okay, so just like here we took the what? The differential of f and then the differential of g, so we are applying the same method, okay? When you take the differential of this expression, so we have x and e exponent x, x, right? So we end up with what? E exponent x, okay, and then plus, so like differentiate, you keep one, differentiate the other, and then you keep the other, and then you differentiate the other. It's like the chain rule, okay? And then we end up with what? Another e exponent x, okay? So now let's put this in this form, okay? Right, so we have e exponent x, and then we have x e exponent x, okay, and then we have the differential, okay, and then we have that. Okay, right, so let's do the simple subtraction, and then we'll be done, okay? So this multiplying that, okay, so we have e exponent x multiplying e exponent x plus x with what? E exponent x, okay, and then minus what? This one multiplying the other one, we have e exponent x multiplying what? X e exponent what? X. So let's try expand, okay? So e exponent x multiplying e exponent x, we have what? E exponent 2x, and then we have what? E exponent x multiplying what? X times e exponent x, so we have x e exponent 2x, okay, and then we have minus e exponent x multiplying by e exponent x, we have what? X e exponent 2x, okay. So from here you could notice that this has become very, very simple, because this will just cancel this out because that's 0, so you'll be left with what? E exponent 2x, okay. So from here you can notice that Wronskian, okay, is not equal to 0, okay, right? So since it's not equal to 0 and then it's something other than 0, per our rule over here, you notice that once this is not equal to 0, okay, it means that it's what? Linearly independent. But once it's equal to 0, it means that it's what? Linearly dependent, okay. Again, we can notice that this is not equal to 0, okay, so this expression is also what? Linearly independent, okay. Right, so I guess this brings us to the end of this tutorial video. I would urge you to like the video, share, and then in case you have any question, just leave them in the comment section and I'll reply to them. I'll reply to them as soon as possible, okay. kindly subscribe to the channel and then turn on your post notifications so that you don't miss out on any uploaded video. And I will see you in the next video. Bye bye.